In this screencast today, we are going to look at how do we write formulas for ionic compounds. And we write formulas for ionic compounds using a method called the crisscross method. Think about when you were in elementary school and you were asked to sit crisscross applesauce. How did your legs go? If you said that they formed the shape of an X, you're correct, and we do the exact same thing when we're writing formulas with our crisscross method. We make an X to change the charge to the subscript. So I'm going to show you some examples of how that works here. So here we have an example of a calcium ion, which has a +2 charge, and a phosphide ion, which has a -3 charge. When we crisscross, what we do is we take the charge for the one element and we cross it over so it can become the subscript for the other element. So again, we take the charge and we crisscross it over. So when we do this, okay, our formula is going to end up being Ca, which will have a subscript of 3, and then P, which will have a subscript of 2. Okay, notice a couple of things here. First of all, I did not change the charge. I didn't move the plus or the minus. The only thing I move is the number itself. Okay, why do I do this? Well, if I have 3 atoms of calcium and each atom of calcium has a +2 charge, then my overall positive charge is going to be +6. And if I have 2 phosphide ions and each phosphide ion has a -3 charge, then my overall negative charge is going to be -6. So what is the overall charge for my molecule? +6 and -6 cancel each other out, so my ionic compound has no charge, it's neutral, which is exactly what happens when we form ionic compounds. Pause the video and write this example down in your notes. When you're finished, push play to go on to the next example. Here's another example of our crisscross method. In this sample, what we're going to do is we are going to take our 1 and cross it over to become the subscript for chlorine. We take the -1 and we cross it over to become the subscript for sodium. Now here's the trick. When we write formulas, we never write a subscript of 1. So even though the 1's cross over, when I write my completed formula, all I'm going to write is NaCl. Just having the symbol there indicates that there is 1 atom of that element, so writing the 1's is not necessary. Again, please pause the video and write this example down in your notes. In this example, we're going to cross the 2 from calcium over to our oxygen, and we cross the -2 from oxygen over to calcium. And this would give us a formula of Ca2O2. One of the rules when we write formulas is that our subscripts here must be in the lowest whole number ratio. Because both of our subscripts are 2's, they can cancel each other out. So when we write our final formula, the formula will actually just be CaO. Again, pause the video and write this example down in your notes, please. This example includes a polyatomic ion. OH-1 is hydroxide. We're going to solve the problem just like we've been doing. So I move the 2 from my calcium over to hydroxide, and I move the 1 from hydroxide over to calcium. And when I write my formula, I write calcium with no subscript because remember I don't write 1's, and then I write hydroxide and my 2 as a subscript. Now here's the problem. If I just leave my subscript 2 outside like this, what the formula is telling me is that I have 1 atom of calcium and 1 atom of oxygen and 2 atoms of hydrogen. And this is not the case. In fact, what I have is 1 atom of calcium and 2 hydroxide polyatomic ions. To show that the 2 applies to the entire polyatomic ion, what I have to do is I have to write parentheses around my polyatomic ion. And this now indicates that I have 2 hydroxide groups. So whenever we have a polyatomic ion and we have to add a subscript to that polyatomic ion, then our polyatomic ion must go inside parentheses. Please pause the video and copy this example down in your notes. Here's another example with a polyatomic ion. Again, we move the number over for both of our cation and our anion, and then we rewrite our formula. In this case, our formula will be magnesium with a subscript of 3, and then phosphate with a subscript of 2. Again, because I moved a subscript over to my polyatomic ion, I'm going to put my polyatomic ion in parentheses. Please notice that the subscript of 4 with the polyatomic ion did not change. When we write formulas, we cannot change the subscripts on polyatomic ions. All we can do is move the number from one ion over to be the subscript for the other. Please pause the video and copy this example in your notes. This example includes two polyatomic ions, ammonium, which has a +1 charge, and phosphate, which has a -3 charge. Again, we move the number for the charge for our cation over to be the subscript for our anion, and we move the number from the charge for our anion over to be the subscript for our cation. So for our final formula, we have NH4, which has an added subscript of 3, and this means that NH4 has to go in parentheses. And then we have our final polyatomic ion, PO4. Because no number has to be written as an additional subscript for PO4, because we don't write ones, the PO4 does not have to be in parentheses. So our final formula is ammonium in parentheses with a subscript of 3, and then phosphate. Please pause the video and write this example in your notes. At the end of the notes that you've written, please include the following 4 practice problems. Write the ion symbol with the charge for each element or polyatomic ion that is listed, and then show how you crisscross the charge to become the subscript. Write your final answer as the formula for the combination of the two ions. Please combine lithium and carbonate, barium and oxygen, potassium and nitrate, and ammonium and sulfate. When you are finished, please make sure you either turn in your handwritten copy of your notes and practice problems to Mrs. Benke or upload them into Schoology as a file picture. If you have any questions, please make sure you bring them to Mrs. Benke's attention so that we can make sure that you are writing the names or the formulas of ionic compounds correctly.